Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Alright, so now we are continue our lecture in chapter time domain analysis part 3. Okay. So for the previous lecture, we learned about the two response or the total response that need to be considered in a linear time invariant system. Okay, so the total response has to be the sum of zero input response and zero state response. Okay, for the previous lecture, we have learned what is zero input response. Basically, when we want to check what is the response if the input is equivalent to zero. Okay, for the zero state response is where the initial condition is equal to zero. Okay, and today we will learn about convolution integral. Okay, what is convolution integral? Basically, it's also a type of response that use convolution. Okay, so the derived integral equation occurs frequently in physical sciences, engineering, and mathematics. That means we are going to see this convolution integral most of the time in our analysis. Okay, basically for physical science, engineering, and maths. Okay, I'm sure you have also learned the convolutions in your mathematics. Okay, so what is convolution? Basically, when we have x1t and x2t as the two different function, okay, we want to convolve it, we put the symbol asterisk here. Alright, so it's different with multiplication. Okay, so what convolve mean? It's mean that we want to multiply the first signal with the second signal that is reflected and shifted. Okay, reflected by minus t and shifted by t dt. Okay, and we integrate it. That means we want to find the area under the first signal and the second signal with this criteria. What criteria? Shifted and also reflected. Okay, we will consider the convolution is a linear because right now we have to consider under the LTI system. Alright, so it will obey the principle of superposition. Okay, so the next one, if we assume the response decay from t equal to 0 to t equal to 1, which is this ht. Now we also have xt as the input. Okay, so what we want to do now next is we multiply the xt with ht, but the ht is shifted by t and reflected. Okay, so we can see that now. Okay, the function is in the form of tau. Okay, so you will see here also that the tau is reflected by putting a minus here. So from this side, okay, it will become this reflected, and now it shifted by t also. Okay, so this is t. So that is basically what is a convolution integral. We multiply the signal with the second signal that is reflected and shifted. Okay, so the shaded area here, okay, will be sum or plus from all the xt and ht. That is the convolution integral. Alright, so as I at least explained, the summation of this weighted input is the convolution integral. Basically, integral is also a summation under the area when we break or chunk each of these pulses. Okay, next we learn also about the properties of convolution. Okay, because we will deal with these two functions most of the time, so we want to know what is the properties. The first one is the commutative property. So if you have two signal, x1t and x2t, so the operand doesn't matter. That's mean if we shifted or swap the second signal with the first signal, the result will be the same. The second one is associative property. Okay, so associative mean x1t convolve with x2t and x3t. So it is also the same with x1t, convolve first with x2t and then we convolve it again with the x3t. Okay, so we also bear in mind that this convolution integral is under the linear time invariance. That means we can do the these properties because of its conditions, linear time invariant. Okay, and then the distributive property, that which is x1t convolve with x2t plus x3t. So that means that x1t will be convolved with x2t and x1t convolved with x3t. Okay, so this is showing the linearity property, which is when it added by signal, each signal x1t and x2t, it can be also added by its derivative. Alright, and then we have shift property. Okay, if x1t convolve with x2t equivalent to ct, okay, then we have this x2t is shifted by minus t, big T. So that's mean it will be equal if we shifted this minus t at x1t and convolve with x2t. So the result will be ct minus big T. Okay, so it doesn't matter if we shift here or we shift here. So the result will also be shifted. And also if we shifted the first signal with T1 and shift the second signal with T2, that means the output will be shifted by T1 and T2. Okay, it shows also the linearity property. And then for impulse property, so this is very special signal, impulse or delta t. So when something or any signal xt is convolved with a delta t, so yes, the condition must be this signal have to be shifted and reflected t minus tau d tau, but at the end the result will be only xt as the output. Alright, the next one is the width property. Alright, so if we have a signal that has a duration or width of t1 and the second one is t2, then the convolution of these two signals will be, the size will be equal t1 plus t2, right? And for causality, if we have xt convolved with ht, okay, that means we have the signal, if for causality That means it will only appear at present and the future. Okay, for the t minus 0, sorry, t less than 0, it will become 0. So this shows that the system is causal. Okay, because it only exists at t larger than 0. Alright, so just now is the input is real, but if it's complex, that means we have the imaginary part jxi, imaginary t. So if we convolve this with a response, so that means each of the part, real part and imaginary part, will be convolved with the ht. Okay, so that means we do it individually. Okay. So basically, if we do this convolution repeatedly, so we will see a pattern. Okay, so this pattern have been analyzed and researched. So they have concluded it with a table. Okay, so what happened if xt convolve with a delta t minus t? Okay, so as I said just now, if you convolve a signal xt with a function delta or impulse, the result will be the same of the original signal xt. Okay, but of course this one is shifted and then we follow. This is under the properties. Okay, and then if we want to convolve e lambda t ut, and the second signal is a ut. Okay, so you just have to identify what is the value of the t. Okay, so you put it here as a constant, and then you substitute with this equation 1 minus e lambda t divided minus lambda multiplied by ut. So ut basically is described as a causal. That means you just want it happen from t larger than 0. Okay. And then for if a signal, step signal ut multiplied by a ut, okay, so the resulting convolution will become tut, okay, and so on and so forth. If you want to know the, like this one, that means the first signal is different values of the roots lambda 1 and lambda 2. It's different, so the resulting convolution is this one. But if the signal, first signal and the second signal is the same, okay, the convolution is this one. You can refer to the table, just identify the signal, first signal and second signal, which one is according to the table. So there are a lot of choices that you can use, right? So the next one, we still in the convolution integral. Okay, just to recall again, if you have two signal x1t and x2t convolve, that means the first signal is multiplied by the second signal, but you have to reflect it and shifted by t. Okay, this is a general equation of a convolution, or a definition of a convolution integral. Okay, so in other words, the output is the sum, or we can say the integration of a scaled. Why scaled? Because this one, if there is a value here when we substitute, so it becomes scale, and also shifted. Okay, shifted by the impulse response. Okay, so again, how we want to solve. Okay, how we want to solve. For example, the first equation or the first function and the second functions are not described as in the table. Okay, so we have to solve it by ourselves. Okay, so the first step is we identify what is the first signal xt and the second signal ht. okay, and then we draw them in tau axis. That means we no longer using the t, but the t is now become tau, okay. So whatever the function, you change in to tau axis, okay. Then rotate one of the signal, usually the second one ht, because it's the same whether you choose any one, okay. But let's fix the second one to be ht about tau equal to 0, okay. For the first example just now, the signal is like this, right? So we have to rotate. Okay, rotate it. If just now is like this, so the rotation will be like this, okay, because we not yet shifted, okay. Then we have to shift the rotated signal ht minus tau, okay, this one. This is an example only, yeah, to the right by t, okay. Now our job is to think how many condition, okay, to be shifted. Okay, so for the first one, before we going step side by side, all right, now we have rotate and shifted the ht. Now we multiply with the first signal xt, okay, with what? With the flip and shift version of ht. Now we have to shift this one into t, okay, t, and this is tau, different, yeah. And then since it is a integration, we have to calculate the area under this product using the correct limit. So this is what integration, okay. Now we want to repeat, okay, step 4 to 5 over a specified region, okay. So if we have covered all the region, that means we have to repeat it for the, maybe we want to check for what happened at this region, number 1, okay, and what happened to this region if it multiply to each other, ht and xt, okay. We can like just put xt to become like this. This is xt example, yeah, okay. And then what happened if xt and ht at this region, okay. We will see a example, okay. For example, we have the signal xt and ht, okay. So xt is defined by a 0 0 and then 1 2 3 4 5 6, okay. The second one, okay, we just make it the same, but this one I have 1 2 3 4, this have 1 2 3 4 5 6, this one have 6 values, this one have 4 values, okay. 1 2 3, 1 3 4. Okay, now we want to convolve this one and this one. Okay, remember the step is we have to rotate the ht. Okay, now we have rotate the ht. Okay, so now just now ht is like this. Now it become like this. Already rotate. Okay. The second one we have to shift. Okay, we have to shift step by step according to the region. So for this example, the related region will be this one, okay, until this one, okay. So let's say we don't shift anything, that's mean n equal to 0, okay, the first step. we don't shift yet, yeah, so this equal to 0. Okay, minus m is actually the axis here. Okay, m, so it's already shifted, hn, m minus negative m. Okay, so when you multiply this one with this one, you got 0. The second one got 0. The third, fourth also got 0. And then you continue the next one, 0 with 1, 0, 0 with 1, 2, 0, 0, and so on. You got 0. Okay, so for the first summation, or n equal to 0, means you don't shift only, you rotate only, you got the 0. And then you shift this h, okay, to the second one. And when you multiply at point 0 and 0, you get 0. And also the rest, when 0 multiplied by numbers or constant values, it will become 0. Okay, so what happened if we shift again? Okay, right now the point 0 multiplied by this one, the value is 2. Okay, 1, 2, 3, 4. Okay, you multiply this one, 0, 0, 0, but 1 here multiplied by 1, 2, 3, 4, 5, 6. Okay, 1 multiplied by 1, you got the 1 here. Okay, so for the first shift, n equal to 2, the convolution sum is 1. Okay, and then you shift again the third one, you multiply this one, 0, we put a name here, the value until 6. Okay, so for the first one is 0, the second one also 0, and then this is 2, right? 2, 1, 3, 4. So 2 multiplied by 1 equivalent to 2, and then the next one, 1 multiplied by 2 is equivalent to 2. So 2, the first one, and 2, the second one, the sum of this convolution is 4. Okay, the next one is also the same. When you already rotate and shift this one, then you multiply with this one, 0. Okay, and then 1, 2, 3, 4. Okay, and then this one is 1, 2, 3, 4, 5, 6. Okay, so you multiply 3, 4 with 0, 0, 3 with 1 is 3. Okay, and then 2 with 2, the second one. Okay, 4, 2 with 2 is 4, and then the third one is 1, 1, and 3, which is 3. So you sum 3, 4, and 3, you will get 10. Okay, you have to shift again until every point with values got, you will sum every point and until the n will be 0. Okay, so again you will multiply the first one with this one, 1, 4 times 1, 3 times 2. Okay, 2 times 3. Okay, and 1 times 4. Okay, so this one, 4 times 1, 4, the second one, 3 times 2, 6. Number 2, 2 times 3, 6. And then 1 times 4. Okay, so 4 plus 6 plus 6 plus 4 is 20. Okay, and then the next one, again you repeat the multiplications of the shifted and rotated value of the second function ht, and you will get the summation. Okay, summation of each one here. Okay, so when we plot, it will be increasing. Okay, and shifted again, increase again until you get a 0. That means you already passed the region. So what kind of region? First of all, it started with 0, and then we have a value increasing and decreasing, and it's at the end it will become 0. Okay, so I will stop up to this example, and we'll continue in next class. Okay, that's all. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi taala wabarakatuh.